In this example, we're asked to evaluate the definite integral from 0 to 4 of 6x squared minus 8x minus 2 dx. Step 1 is going to be to find the antiderivative. In other words, we're going to start very similarly to what we would do if the problem was just indefinite integral of 6x squared minus 8x minus 2 dx. So we're going to start by integrating, which will give me 6/3 x cubed minus 8x squared over 2 minus 2x. Now, if we were just finding the indefinite integral, we'd have a plus c there and we'd be done. But in this problem, we want to take our antiderivative, and by the way, in this context, we don't put in the plus c, but we want to take our antiderivative, plug in a 4, plug in a 0, and subtract those two things. And the notation for this is the vertical line at the end with the 0 and the 4. And you do need to use this notation. And you don't put in a c. The c's would just get canceled out when we subtract it anyway, so there's no point in complicating the problem. Let's go ahead and simplify this. So we have 2x cubed minus 4x squared minus 2x. And again, I need this notation to indicate I'm not indicating just that expression, but I'm indicating that I'm plugging two numbers in and subtracting. Step 2 is to do that plugging in. So step 2 is plug in what's called the limits of integration. These numbers that are on the integral, those are called the limits of integration. I don't like that terminology. I think it's confusing because these aren't limits, they're just numbers we're plugging in. But no one asked me what we should call those things, so we're stuck with the standard terminology. Okay, plugging in. I'm going to plug a 4 in. So I'm going to have 2 times 4 cubed minus 4 times 4 squared minus 2 times 4. And plugging in the 0, I'm going to have 2 times 0 cubed minus 2 times 0 squared minus 2 times 0, and then I'm subtracting those two things. So in other words, this is what would correspond to our capital F of 4, and this is what would correspond to our capital F of 0, and then we're subtracting. So if we do that, let's see, 4 cubed is 64, so I have 2 times 64. 4 times 4 squared is 64, and I have minus 8. All the stuff in the second set of parentheses is just a 0. So what do I end up with? That's going to be 56. Let's try another example. Let's evaluate the definite integral from 1 to e of 5 over t dt. Step 1 is to find the antiderivative, and remember, constant coefficients can be pulled out front. So I've got 5 times whatever the antiderivative of 1 over t is, dt, and we know that's going to be the log of the absolute value of t. Then I'm not going to put in the plus c. I'm going to put in the vertical bar with my two limits of integration. And again, you do need to use this notation and don't put in a C. So I have 5 times. Now putting in those numbers, ln of the absolute value of E minus ln of the absolute value of 1. Those absolute value bars aren't actually doing anything because E is positive and 1 is positive. What's the natural log of E? It's just 1. What's the natural log of 1? It's 0. So we wind up with 5 as our final answer.